everyone, in this video we are going to discuss about oxidation number. And we can simply define oxidation number as the formal charge assigned on the atom if the bonds are considered to be ionic. If the bonds are considered to be ionic. Then what are ionic bonds? Let's see. Atoms except those of noble gas do not have free existence. They readily combine with one another to form new molecules. That we know. An ionic bond results from complete transfer of one or more electrons from outermost shell of one atom to another. In this way, both atoms acquire electronic configuration of nearby noble gases and get stabilized. An atom which lose electron acquire a positive charge and the atom which gain electron acquire a negative charge. And we call them as positive and negative ions respectively. There is electrostatic attraction between the oppositively charged ions, that is the positive and negative charged species. Okay, this type of attraction result in the formation of new bonds between them called ionic bond. Okay, and finally get stabilized. This is what happening in ionic bond. Let's discuss an example, formation of magnesium chloride, MgCl2. Here magnesium having atomic number 12 and the electronic configuration can be written as 2H2. Here magnesium having 2 electrons in its outermost shell. So magnesium can attain stability or can complete the octet by losing these 2 electrons, or it can accept 6 electrons to it. Okay, but this is not too much easy to accept 6 electrons. The simplest way is to lose 2 electrons. So it prefers to lose 2 electrons and exist as a positively charged ion, that is Mg2+. Here we have the equation as Mg giving Mg2 plus 2 electron. Okay, then in the case of chlorine, the atomic number is 17. So the electronic configuration can be written as 287. That means outermost shell having 7 electron. So it can attain the stability by gaining of 1 electron or by losing 7 electron, but it is not too much easy to lose 7 electrons. Okay, from the outermost shell it is more easy to accept 1 electron instead of losing 7 electrons. So it preferred to gain 1 electron instead of losing. The most simplest way is to gain 1 electron. So chlorine prefer to gain 1 electron and exist as a negatively charged ion. Here magnesium losing 2 electron and each of these 1 electrons will be accepted by 2 chlorine atoms. That is 1 electron will be accepted by 1 chlorine atom and the another will be by another chlorine atom. Okay, we already defined about the oxidation number, that is the formal charge assigned on the atom. Here magnesium having 2 positive charge, so the oxidation number is +2. We defined it is the charge assigned on the atom. So here magnesium having 2 positive charge, so the oxidation number is +2, and the chlorine have 1 negative charge, so the oxidation number is -1. Let's see how oxidation numbers are taken in the case of covalent bonds. Okay, then what about covalent bonds? Atoms may combine with one another by sharing of electrons in their valence shell, so that the combining atoms attain the nearby noble gas configurations. So the both atoms get stabilized. This type of linkage is called covalent linkage or covalent bond. Okay. HCl is a covalently bonded compound. Here chlorine is most electronegative atom. Here one pair of electrons are shared between hydrogen and chlorine. We know electronegativity is the ability to attract electrons. Here chlorine is most electronegative atom, so it have a tendency to attract the electron pairs more towards it. Okay. As a result, it get a partial negative charge and hydrogen get a partial positive charge. Okay. So the oxidation number of an atom in a covalent compound is found out based on the shifting of electrons. From where to where? Here electrons are shifted from hydrogen to more electronegative chlorine atom. So hydrogen become positively charged species and chlorine become a negatively charged species. Okay. Another important point is that oxidation number of an atom in a molecule of an element will be 0 as the electrons are shared equally between the atoms. Let's see hydrogen molecule in the reactant side. Here the electrons are shared equally between the atoms. There is no electronegativity difference between these two atoms because these are same. So oxidation number will be 0 because there is no charge separation, there is no electronegativity difference, no charge separation. So the oxidation number will be 0. Another important factor, the sum of the oxidation number of constituent atoms in a molecule will be 0. Here we know oxidation number of hydrogen is +1 and oxidation number of chlorine is -1. So the sum will be 0. So the sum of the oxidation number of constituent atom in a molecule will be 0. Let's define oxidation and reduction in terms of oxidation number. The process in which the oxidation number increases is called oxidation and the process in which the oxidation number decreases is called reduction. Here oxidation number of hydrogen in the molecular state is 0 and after the formation of HCl it increased to +1 and the oxidation number of chlorine in the molecular state is 0 and after the formation of HCl it is decreased to -1. So the oxidation is for hydrogen, that we already defined that the process in which oxidation number increases is called oxidation. So here oxidation is for hydrogen and the process in which the oxidation number decreases is called reduction. So the reduction is for chlorine because the oxidation number is decreased from 0 to -1. So the reduction is for chlorine and we can say here the reducing agent is hydrogen and oxidizing agent is chlorine.